So, all right, well, folks, I'm going to go ahead and we're right at the top of the hour, so I'm going to go ahead and get started on this. Um, as some of you may know, hello, I'm Dr. Brian Kloppenborg. I'm the new executive director of the AAVSO, and I'd like to welcome you to AAVSO's summer webinar series that focuses on our observing sections. In this webinar today, we're going to be talking about AAVSOnet, the high energy network, the instrumentation and equipment group, as well as the long period variable section. And I'm joined today by Dr. Arne Henden, Heinz-Bernd Eggenstein, Peter Bealo, and Mike Soukup. So we'll get to them here in just a few minutes. So I'd just like to show you a couple things about the Zoom webinar in case you haven't been in one of these Zoom sessions before. I'd just like to note that you have a couple special features that you can use in order to communicate with us, the panelists, as well as the other folks that are listening here to the webinar. The first of which is at the bottom of your screen, there's a series of buttons. You can use the chat button to go ahead and introduce yourself and just say hello. If you have any questions during the webinar, please use the Q&A box instead down at the bottom of the screen. Type in your question there, and it shows up in a nice list that allows me as the moderator to be able to ask the panelists the appropriate questions. And then lastly, we're also using, Zoom has a closed captioning feature. If you do turn on the closed captioning feature, please note that the language that you need to select is the language that's being spoken. So in this case, it will actually be English. And so just make sure it's selected there. One other thing I'd like to point out is that we have another webinar series that's actually up and running. And so this other one, the title translates to The Science of the Sky for Beginners. It's an all Spanish speaking webinar series. The next one will be coming up in a couple of weeks. And so if you happen to know somebody that's a Spanish speaker, we'd love to have them participate. And please give them the URL. You can go to aavso.org and then 2023 Seminaros web. That'll get you to that link. And I'd also like to say a special thank you to our sponsor, Voice Astro, who without which we wouldn't be able to bring you these webinar series. They're actually sponsoring the entire webinar series for AAVSO for the whole year, all in one go. And so I'd like to honor them and thank them for their generous support. And in case you haven't heard of them before, the Voice Research Initiative and Education Foundation, they provide online astronomy education, observatory resources, and research experiences to students, student teams, and schools to learn how to perform observations, conduct research, and publish their results in scientific journals like the Journal of the American Association of Variable Star Observers. So please do check out their webpage there at voiceastro.org to learn a little bit more about them and the work that they do. All right, so I'm going to switch slides here really quick because I get the first 5 sections of, or first 5 minutes of the presentation today to talk just a little bit about the AAVSO. So let me switch over to my other screen here. All right, and so you guys can see the new slides, right, Arne, HB? Yep, okay, all right. You know, all of you are here today. You probably have heard about the American Association of Variable Star Observers before, but just in case you haven't, I'd like to provide a little bit of context to who we are and what we do. And so the AAVSO is a 112-year-old nonprofit that focuses on science of astronomy. And our mission is to enable anyone, anywhere to participate in scientific discovery through variable star astronomy. And we achieve this mission primarily through establishing collaborations between professional astronomers and amateur astronomers. But we also have a variety of strategic partnerships, like our collaboration with Exoplanet Watch, educational activities, as well as data stewardship that we do as well. Now, in case you're wondering, you know, who are the AAVSO, right? Because we're a group of not just folks there at headquarters, but also a group of participants. The things that unify AAVSO members is basically that, you know, they have a fundamental interest in astronomy, and they all have some way that they want to be able to contribute to science. But beyond that, the group really becomes quite diverse. You can see in the upper right-hand corner our picture of our last annual meeting. There were about 110 people that we had in the room. Most of our observers, we have about 10% of our members that they need some form of education, training, or guidance on how to conduct variable star observations. Then we have about 80% of our members who are actually working directly with professional astronomers to conduct scientific research. And then we have somewhere between 2 to 10% that are conducting their own forms of independent research. Now, AAVSO members use a wide variety of different methods of doing observations. Some people are observing by using their eyes, others are using DSLR cameras, and yet others are using other digital detectors like CCD or CMOS sensors. In terms of the equipment that they have access to, they might have nothing but their eyes, and then some others have access to meter class telescopes, and they use a wide variety of different tools in order to accomplish their work. So in the lower right-hand corner, you can see here Roger, he likes to do visual observing, and so there he is posing with his telescope. Dr. Mario Mota, he actually built his own 80-centimeter telescope, and then Sansu there, he's built a solar telescope on his own. So you can see, despite if you don't have access to a telescope, there certainly is definitely a way that you can get involved with AAVSO. One slide that I always like to show to talk a little bit more about the AAVSO is this one here, which is describes AAVSO in terms of numbers. We presently have about 1,200 members, 800 observers, and about 200 volunteers that are helping us achieve our mission. We conduct a wide variety of education and public outreach activities, including a webinar series, which is this one here, as well as our Spanish-speaking webinar series. In the chat, there was a little bit of discussion about our choice courses. And so we have 10 continuing education courses that we offer per year with about 125 participants in total. We also have a wide variety of observing manuals that help you get interested and learn on how to do variable star astronomy, either by eye or using a camera or using your telescope. And they've been translated into 13 different languages. And one of AAVSO's most attractive things is that we also have a mentorship program. So once you become a member and you're trying to learn how to do variable star astronomy, we can assign a mentor to you, and they can help you by answering the various questions that you have. Now, AAVSO, of course, is a science-focused nonprofit, and so I'd like to highlight a few things on how we actually contribute to science. The first of which is that data from our members are used in about 380 publications per year. And so if you do the math between 800 observers on the left-hand side and 380 publications per year, you have roughly like somewhere between a 40 to 50% chance at random of just being involved in the publication, which is pretty good for just going out and doing data collection. We also maintain the world's largest photometric database of data collected by amateur astronomers that presently has about 55 million observations. We have a curated database of variable star metadata, and so this is information about different types of variable stars with about 2.2 million entries in there, as well as a spectroscopic database, a database for exoplanets, and a peer-reviewed journal. Now, today, of course, we're going to be talking about the AAVSO sections, and I'd like to provide a little bit of context into what a section is. So their purpose is primarily to organize and support efforts to observe and record data on variable stars, the sun, exoplanets, or other celestial objects. And the way that they're organized is they usually have a section leader, which are the four folks that are here talking today are their section leaders. They often have a science advisor, and then a large number of participants. And anybody can actually join and become a participant in the sections. And after this talk is done, in case you're curious on how to join the sections, please visit the URL that's down at the bottom left-hand corner of the page, which is aavso.org/join-a-section. So our speakers today, as I mentioned a few moments ago, Arne Henden will be talking about AAVSOnet. Mike will be talking about long period variables. HB will be talking about the high energy network, and then Peter will be talking about instrumentation and equipment. And so with that, I'm going to go ahead and stop sharing my screen. And then Arne, if you'd like to go first, I'll let you share your screen. And then again, as we go through the presentation here, if you have questions, please use the Q&A button, and we'll defer all questions until the end of the program. So let's all welcome Arne.
Yes. Okay. Well, thank you, Brian. I've given lots of talks about AAVSOnet, but I'm going to talk about the section this time. So I'll start out with the usual information about AAVSO, what AAVSOnet is about, and how you can ask for observations from it. But I'll also mention sort of the background. Who are the people involved in AAVSOnet, and what are they doing, and how you can also be involved if you want to. So AAVSOnet is a remotely accessed set of telescopes. There are currently 9 of these telescopes distributed worldwide. This network started 16 years ago, it seems like. We started with the Sonoita Research Observatory telescope down in southern Arizona, and then expanded beyond that to telescopes in other states as well as worldwide. And it actually delivers quite a number of images. About 3 million images have been taken to date. This network is not being run by staff or paid people. It is a purely volunteer-run network, and it's run for the benefit of AAVSO members. So if you are a member, you are able to participate in AAVSOnet. And roughly about 60 users are using the system at any given time. One of the nice features of AAVSOnet is it not only allows you access to telescopes, but the images that you get off of those telescopes have already been calibrated. They've been dark subtracted and flat fielded and placed in a spot that is convenient for you to gain access to those images. So the telescopes, like I said, are distributed worldwide, sort of, in the sense that we have southern telescopes down in Australia and New Zealand, and lots of northern telescopes in North America, but we don't have anything in Africa. We don't have anything in Europe. So the longitudinal distribution is not great. The latitudinal distribution is actually pretty good. There are 2 different types of telescopes that are in the network. There's a bunch of small telescopes, sort of 7 to 8 inch aperture, mostly Takahashi E180 astrographs. So they're very nice telescopes. They give a very wide field of view. You can go down to sort of 14th magnitude in a variety of filters, not only Johnson Cousins, but Sloan and H alpha and a number of others. These are still, even though they're small, they're still expensive telescopes. The typical equipment cost per site is about $40,000 if you went out and tried to buy this equipment brand new. And then we also have a number of faint star monitors, as we call them, telescopes in sort of the 20 to 24 inch class. It'd be nice to get some bigger ones, but those are the ones that we have available. And those are generally partnerships. The telescope is owned by a university or some sort of consortium, and we are given access to that telescope, a fraction of the telescope time. They go quite a bit fainter. Usually they're in very nice sites, so you get good resolution, spatial resolution, as well as dark skies. This is a typical one of these Takahashi E180 systems. This one is in Hawaii. This is a typical one of the faint star monitors. This is the MPO system in Texas, a nice 24-inch RCOS. The observers with AAVSOnet generally contribute their data to the AAVSO through the for WebObs and the AID. This data from Frank Shore. He is monitoring a number of long period variables. You can see the data comes in multiple band passes, as well as quite a bit of coverage on these stars. And we can also do very precise measurements as well. This comes from Dennis Conti and George Silvas. This is an exoplanet transit, 1% type transit, and it was able to be detected with one of the E180 systems. So why would you use AAVSOnet? Perhaps you live in an urban environment. You live in downtown Boston, you live in Houston, you have a bright sky, you can't do anything from home. You generally have to go out to a dark sky site. Well, here you can do it from your own living room. You may be in an area where there is no space for your own telescope. Brian lives in a condo in the Colorado area, and his HOA does not allow you to put out a telescope permanent structure in the common grounds. Well, this is a way in which you can gain access to a very nice telescope elsewhere. You may be in a northern hemisphere and there's a campaign object in the southern hemisphere, and vice versa. And like I said, this equipment is quite expensive. And if you're just jumping into it for your first time, you may not want to put one of these systems together. This is a way in which you gain access to the equipment sort of as a test run before you go and try to do anything on your own. And even if you don't want to build your own robotic telescope, this is a way in which you can learn to do photometry and spectroscopy by using equipment that's available to you. And like I said, it's a membership benefit. So if you're an AAVSO member, you have access to the network. No hourly fee. You don't have to pay money to a robotic system. But at the same time, that means that you have sort of less access. You could buy all the time on some robotic telescope farms telescope if you had the money. But in this case, you generally have to submit a proposal. It's very simple, stating what kind of a target you want to observe and why you want to observe it. And then we will grant you time on the network to do that. There's time that is available. And then again, like I said, you get these images back to you already calibrated, so you don't have to do that critical step. This is the proposal form. I was told and confirmed that this form is not working right now on the website, but it's something that's been there for a long time. I'm sure it'll be working again shortly. The main thing to remember on this is that there's a box here in the middle. It says proposal. And what we want you to do is to give us a few sentences of why you want to observe this object. You may say, well, this is a campaign target for HST and they want us to monitor. Okay, well, that's fine. Or you may want to observe the star because it's a new type of variable that you've never looked at before. But just give us a clue as to why you want to observe the object. And then while this only shows one box down here, you can add in as many targets as you wish. The more targets, the more telescope time you're going to be asking for. And so the more you really ought to justify why you need that telescope time. But if you're looking for one object, it's no problem at all, just submit something. But this is also the AAVSOnet section. And so it's actually pieces of many other sections. The observations I mentioned before, people are observing different types of variable stars. Well, there are sections devoted to those, but there's this overlap with AAVSOnet. There's an instrumentation section in which you can discuss various aspects of automated telescopes and robotic photometry. But you can also do that here with the AAVSOnet. And then there are lots of aspects of automated pipeline photometry that involves any kind of software you can think of, from basic scripts to very complex database management issues. So those are also available in the software section, but you can discuss them here as well. And you can discuss these through our forum. There is a forum for AAVSOnet. You can ask questions. You can discuss various features. You can make suggestions for the future of the network, where you want to see it expand. And in addition to this, you can also volunteer for helping out with AAVSOnet. Like I said, it's a volunteer-run network. That means that there are people that have to host systems, do the programming, and et cetera. Or you can just use the network for doing your own observations. So as a volunteer, one of the volunteer sort of positions, if you want to call it, is to host one of the AAVSOnet systems, like one of these E180 systems. They're very small. Typical footprint is about a meter cube, but they need some place to site these systems. There has to be infrastructure such as power and internet that's available. Usually this is in people's backyards, but you may also have a telescope of your own that you may want to include into AAVSOnet. And this is welcome, especially if it's in an area of the globe that we do not currently cover, such as, like I said, South Africa. In order to do this, you would have to probably build an enclosure, or you have a telescope available for us. Once the telescope is delivered, you would have to maintain that equipment, keep the mirrors clean, do any kind of basic maintenance on the mount that would be required. And optionally, you would need to operate that equipment on any clear night that might happen. We can also provide another volunteer who will operate that equipment as long as you give that person permission to do so. The operation of one of these systems is pretty simple. It's basically looking at the weather conditions. If it's adequate, then you would open up at sunset. You make sure the telescope closed down at sunrise. You enable twilight flats if the conditions are adequate for doing so. And you sort of just make sure the system runs smoothly through the night. The other thing is that there are image inspectors, which I'll talk about next. They do reviews on a nightly basis of the data for their particular telescope. And it's good to look at those reviews and see if there's something going wrong with your system, a new flat fielding feature or something that might require that you take things apart and clean it up. All of the big telescopes, the faint star monitor systems, like I said, are partnerships. And in general, they are the ones who own the system and are maintaining the system, but the actual operation may be a volunteer position from the AAVSO and actually to open and close that particular system. So the other aspect I mentioned were to inspect the images. For the 9 telescopes that are there, each one has an image inspector who looks at the images that have been taken and looks for problems. That person is experienced with that particular telescope. And so they rapidly catch any flat fielding issue that might occur, any kind of degradation of the camera equipment or tracking issues or something like this. Those are problems that then get relayed back to the person who is hosting the system to help fix those problems. There's also a group of what we call administrators. These are the people that actually do the background stuff that is required for AAVSOnet. Ken Menzies, for example, handles most of the plan preparation. So after the project has been approved by the telescope allocation committee, Ken is the one who generates the plan that then goes into the observing queues for the various telescopes. The administrators also look at the big picture, see where any problem areas are occurring and try to keep things running smoothly and think about what is happening, where things are going in the future. There's a pipeline, as I mentioned, for doing the basic calibration of the images. There are people involved with that pipeline because it's sitting in the Amazon cloud. So somebody maintains that pipeline. There's Python scripts to do things. There are scripts that are on each of the individual systems to take care of the customization parts of the telescope setup. And whenever a new system comes online, then there has to be somebody that's involved in making sure all the software pieces are installed and are configured correctly. And then there are people like George Silvas who also maintain the website pages. So here's some of the contact information. Post to the forum is the easiest way to get hold of anybody related to AAVSOnet, whether it's part of the volunteer staff or just general community. If you have a specific question and you want an answer relatively quickly, you can go ahead and email the AAVSOnet at this address. You can contact the administrators, or you can actually just email me and I'll make sure that the message gets routed to the right source. On the web, getting to AAVSOnet is not straightforward in the sense that it's not on the home page. But if you go to the observing sections, you can look down through there and you will see AAVSOnet is a link in there, or you can just use the link that I show at the bottom of this page. So I'm going to end there, but I just want to acknowledge that I was talking about the people involved with AAVSOnet. There's also a whole list of people that have either made large financial donations to the network or have, as vendors, donated equipment to the AAVSOnet. And I really appreciate all the work and effort from both the volunteers and all the vendors who have graciously contributed to the network. And I think it's a really cool thing, and I hope that it continues, and I hope that more and more people use it. So that's all I have.
All right, thank you, Arne. We really appreciate it. So if anybody has any questions for Arne, please go ahead and put them into the Q&A box at the bottom of your screen, and we'll route those questions over to him during the Q&A session, which will be at the end of this presentation. All right, so next up, I'd like to go with Peter Bealo, who will be talking about the instrumentation and equipment section. And so Peter, I'll go ahead and pull your slides up here and start sharing the screen. Yep. Arne, I'm going to steal the screen back from you.
Okay. Are people hearing me?
We can hear you, yes.
Perfect.
Can you see the slides?
I can.
All right, you're clear to go. And just let me know when you're ready to advance to the next slide.
Sure. So I'm Pete Bealo. I've only been an AAVSO member now for 4.5, 5 years. I'm INE section lead due to competent people having other things to do. I'm now on the board. I'm also an AAVSOnet image reviewer and AAVSOnet observer. I just quickly want to say that, you know, Arnie's right. It's a really simple system to use. Over the last 4 years plus, I've put in about 15 proposals. 13 have been accepted. And the other 2 weren't accepted because other people were observing the same stars. So, so that's all fine. And the system works great. Next slide. So I'm here to talk about INE section. So we're one of the 2, I guess, non-observing section or non-stellar sections, AAVSOnet and instrumentation and equipment. So in a nutshell, for any ham radio operator out there, there's a long-term position called an Elmer. An Elmer in the ham radio world is somebody who helps along a newcomer or helps other people who have issues or questions on how to operate things progress. The INE section are basically the Elmers for AAVSO, and also the people who ask Elmers for help, for questions. We address any kind of telescope, imager, and accessories questions you might have. Some members are involved in evaluating and designing items to make our observing a lot easier. We have an online forum like all the other sections for asking advice, comparing ideas, sharing progress, whatever. And we support all of the observing sections. Next slide. So presently we have one of our members, Alan Slisky, is working on a new flat field illumination system. He's been through 8 revs now and beta units are available. He's also working on a new weather sensor, help keep your equipment safe. George Silvis is also working on a different flat field illumination system. And there's been a lot of work put into filter characterization. Arne Henden is one of the real movers and shakers in that world. So we're evaluating new filters, developing methods to make filter evaluations, i.e. use spectrophotometers. A lot of talk also in our group about alternate imaging systems. There's been a few threads about how to use your cell phones and actually not bad variable star results off of using cell phones. And there's also been a lot of discussion on using the automated imaging telescopes like the unistellar telescopes and hopefully soon the ZWO telescopes. So we're here to talk to you about systems and how to use them, how to make them better, and design your own if you wish. Next slide. This is just a slide of one of Al Slisky, schematic of Al Slisky's cover calibrator that he's been working on now. The cover calibrator will flip out of the way when you don't need it, and under software control, flip into the in front of the telescope when you do need it. Next slide. And this is just to look at some work from Mike Weiss on evaluating filters, especially on the bottom. You can see the classical Johnson-Cousins filter profiles, and superimposed on that are some of the measurements that Mike had made of one of the newer thin film filters, sets of thin film filters that he evaluated. Next slide. So why am I here? Just to invite you to join the section, share your ideas, contribute any kind of ideas you have on ongoing design efforts, or expose you to some of those design efforts if you want to build copies yourself. Ask questions on any aspect of hardware and equipment design, availability and use. Of course, like every other section, we're open to non-AAVSO members. I guess maybe this may not be the company line, but fundamentally, if you're not an AAVSO member, I hope we give you sufficient value in order to entice you to ultimately join AAVSO. That's my hope, at least. Next slide. I think that's about it. Oh, that's just a picture of our section lead slide. A lot of really good people are involved with this. Arne, Gary Walker, George Silvas, Bob Macy, and others contribute and answer folks' questions and put up their interesting new stuff. Next. Yep, short and sweet. We don't have a lot of physics to talk about, how various variables work and all.
Oh, thanks, Peter, for giving that presentation. The I&E section is kind of like the makers of the AAVSO, if you want to think about it that way. They're always building something new and doing something interesting and attempting to bring new technology over to AAVSO. And also, I will say that the opportunity to talk with somebody to help you troubleshoot your equipment is definitely not something to be scoffed at. So the I&E section is definitely very much appreciated. So next up, we're going to have Heinz-Bernd, and he's going to talk about the high energy network section. So HB, you're welcome to share your screen.
Okay. Hello, everyone. Can you see my screen?
We can see it, and we can hear you fine. Go
Ah,
ahead.
cool. Okay, thank you. Yeah, so my part is about the high energy network observing section, and well, first some fluffy definitions. So we are mostly concerned with transient astronomical events. So that are events that set in abruptly and last mostly only for a short time, and that are kind of unexpected, not periodic in nature, and sometimes from progenitors that were not even known before. And there's this high energy term in our title, which kind of has a double meaning. I mean, it refers to events that involve radiation from the high energy end of the spectrum, or particles like X-rays, gamma rays, cosmic rays, neutrinos. And then we are mostly dealing with optical counterparts to these events. But it also includes events that just release a lot of energy within a short time. So let's step through a bit of history briefly. The section was first established, I think, around 2000 with a razor-sharp focus on gamma ray burst afterglows. That was before I got involved. I think it was a bit dormant for a while, but then was reanimated around 2020, and now has a wider agenda. It now includes still gamma ray burst afterglows, but also kilonovae, AGNs, and the next galactic core collapse supernova. And I'll step through these one by one for details. So it has actually two leads, Dave Hinsel and myself. And it probably is the smallest AAVSO section in terms of participation in the forum, etc. But maybe we can change that. So here's a typical gamma ray optical afterglow. You can see two images, one taken only like a minute after the gamma ray burst was detected, and one after 9 minutes. And what you see is that after 9 minutes, it's almost gone. So yeah, observing these things is all about quick reaction. And how can we actually do that? I mean, first to detect gamma rays, gamma ray bursts, I mean, these things luckily don't penetrate the atmosphere so well. So you need satellites. So the two most significant in this field are the Fermi satellite and maybe even more important, the SWIFT satellite. And both of these satellites have quite a bit of intelligence on board in computers, and the computers will decide by themselves what is an interesting event and what not. And they can actually slew the whole satellite and to look a bit deeper, and with optical instruments and with X-ray telescopes in the case of SWIFT on a burst, and do all that by themselves without human intervention. And they can then radio down alerts, triggers to what is called the Gamma Ray Coordinates Network by NASA. So they will communicate with these ground-based computers, and then those computers, again, without any human intervention, can then send out notifications to people who subscribe to this network, and most of the content is public. So this could be professional astronomers, but also amateur astronomers like you and me. And and sometimes gamma ray bursts are really special. I mean, usually an average of one is detected per day, but there was, for example, gamma ray burst 2020 1009 is a typo A, which happened about a year ago, and which got the nickname BOAT, brightest of all times. The afterglow was visible for many days, actually. It was so strong, the gamma ray part of it, that it actually disturbed Earth's ionosphere a bit. And this got observed by also AAVSO observers like Philip Romanov. And here you can see animation of some frames he took over the course of many days. And that event was so significant that the Astrophysical Journal Letters had a special issue published with just papers about this event. And one of the papers was by Grandma collaboration and others, and they are so kind that they include all the observers that contributed data. And there again, you can see Philip Romanov. So this is still an relevant field of research, even for amateurs. So here's the plan. That's one of the takeaways I want you to have in mind. Let SWIFT, Fermi, and friends discover gamma ray bursts for us, then let the alert systems alert us about it, and so that we can quickly get on our telescopes and make observations of them. Another field are binary neutron stars and their mergers. Binary neutron stars are, just systems of two neutron stars. I won't go into the physics too much here, but when eventually they can merge, and that merging of neutron stars creates gravitational waves, which can be detected by gravitational wave detectors. And after they merge, they create something that is visible also in optical wavelengths, which is called a kilonova, because it's much brighter than a nova, but a bit less brighter than a supernova. And there can also be gamma ray burst coming with it. So two of the most powerful gravitational wave detectors are in the US, and one in Louisiana, one in Washington State. There's another one in Italy as well. And if you want to join this activity right now, you're lucky, because now until the end of 2024 is kilonova hunting season, because these detectors have gone online again after a longer pause caused by COVID and upgrading the detectors. And any day now, we could get an alert about actually what would be the second kilonova observed, both in gravitational waves and in optical wavelengths. So the first one was in 2017, but at that time the alerts were kind of kept secret, so not public. So amateurs had no chance to participate in the hunt for that. And it took 11 hours to spot the optical afterglow, the kilonova. Maybe because the professionals had to wait until Chile came into a position where all the professional telescopes are to observe the event. Maybe it would have been discovered earlier if amateurs had been allowed to join in. But now it's public, and now amateurs can join in. This event would have been, from the brightness, it would have been possible to observe by amateurs. So to facilitate amateurs hunting for kilonova, there's the Kilonova Catcher project, the Pro-M collaboration, and we highly recommend that you join this project if you are interested in events like this. Yeah, let me speed through it. I mean, these are rare events. You can expect to see between 1 and 0 in this current campaign until the end of next year. But because they are rare, they are also precious. I mean, it would be for the second event, we need every single data point that, and as soon as possible after the merger. Okay, then something that we are also interested in would be the next galactic core collapse supernova. So the next supernova that is caused by a core collapse inside our own galaxy. That will be super interesting to observe. And whenever I talk about this in the public, I want to shatter two misconceptions. So the first misconception is that galactic core collapse supernova are super rare. And there have been papers published estimating the rate, and the consensus now is that you can expect between, like, typically maybe 3 per century. So let's say between 1 and a few per century, which means that yeah, you have a good chance to observe the next one, but if you miss the next one, don't count on having a second chance. The second misconception is such an event will be super bright and immediately obvious in the sky, which will likely not be true. I mean, if Betelgeuse goes supernova, yes, you will be able to read a newspaper at night, but I mean, more likely it is that the next core collapse supernova is maybe even on the other side of the galaxy, and then you will have to observe this through a lot of dust. And there have also been papers on that, and I won't go too into the details, but with the DSLR, you have like a 50% chance to be able to observe it, and with a small size telescope, the chances are like 80% to be able to observe it. So not super bright, but also not hopeless. And if you might ask, I mean, if there are 3 per century, why aren't there more in the history books? And the reason is that we missed a lot of them because they were obscured by dust from the Milky Way. But we will not, in the future, we will not miss any more. because we will get a neutrino signal from them, and we now have neutrino detectors. And there's this NEWS, the supernova early warning system driven by neutrino detectors, where you can subscribe, and you will be notified in real time when there's a neutrino alert that indicates that the star has gone kaboom in our own Milky Way, and we encourage everybody to subscribe there. We also keep an eye on the potential progenitors, and not just Betelgeuse. And those are mostly red supergiants. And there's ongoing activity to curate a catalog of possible curators. And there's also a project which was conceived and implemented by Lauren Harrington for observing red supergiants, which I would recommend here. Now, to what I would want people to take away is that you probably don't want to spend the rest of your astronomical amateur life waiting for these things to happen. You have your other projects like observing long period variables, but you should have in your pocket like your cell phone with an application like Astro Colibri that will tell you when interesting transient events happen, like gamma ray bursts or kilonovae or supernovae. These are super useful so that you don't miss such an event while you're anyway at your telescope, and could slew your telescope within a minute to this interesting thing. Yeah, it's available for iOS and Android, and we highly recommend this. Now, if you don't want to hunt these highly transient things, then a more conventional type of target that we're interested in is AGNs, active galactic nuclei, quasi-stellar objects, quasars, which can be variable, but are actually not variable stars because they are caused by jets coming from black holes in the center of galaxies. So they might look like stars because they are so bright and far away that they are point-like sources, but their variability is also very interesting. Some can stay more or less constant for years and years and years, and then erupt and act up and show strange variability. My favorite one is S5 1803 plus 78, which back in 2020, I think, had a flare and never really stopped flaring and acting up since then. And one day somebody might come up with a theory how this actually happens, because it's an active field of research, and then they can look at our light curve and compare their model to our light curve and see if what they think happens is consistent with our data. So what should you do if you're interested in joining our observing sections? Not just subscribe to our section, but you should also subscribe to the SNOOS alert mailing list. You should use something like Astro Colibri to follow GCN, and you should check ATELs and generally be prepared. I mean, have your batteries charged, have tons of storage, data storage ready, and keep your clocks synced, and have lots of coffee and warm clothes at your disposal. Oh, and join Kilonova Catcher, of course. And all of this to avoid a situation like this, that you will be at a party in a couple of years and you have to explain why you missed the most interesting event of a decade or a century. So yeah, that's it from me. I'm happy to answer then questions at the end of this. Thank you.
Thanks, HB. And I especially like the comic here. Hopefully we don't fall in that abducted by aliens category, given all the stuff going on within Congress right now with the UAP hearings.
Yes.
And I will note for the members here that are listening, you know, the High Energy Network has this model of responding to events. And as we look into the future, these large sky surveys that exist, particularly the Vera Rubin Observatory, is expected to generate about 100,000 alerts per night. You should anticipate that, you know, amateur astronomy to make your observations most relevant to professional astronomers will probably have to get into the mode where we're relatively responsive to alerts like this. And so the High Energy Network is actually being a good model for perhaps the way that the future of AAVSO will have to operate. All right, so HB, if you could go ahead and stop sharing your screen, and Mike is our next presenter, and he'll be talking about the long period variable section.
Okay, let me pull up my slides here. Hold on.
Yep, certainly.
Okay. First of all, I'd like to say thank you to everyone who's tuned in. But I also need to say that I'm being told by my hardware that I have an unstable internet connection on my end, so I could disappear at any moment. Just to start off with, look at the magnificent logo we have for the LPV observing section. It's a bit abstract. A very talented young lady who recently graduated from MIT did it for me. And I said, I want something abstract. I don't want a picture of Betelgeuse. And so she came up with this. And if you look at the represents the star here, you see the shaded areas representing sort of the pulsations going on within this object. And then all of this here is basically mass outflow. And stellar winds and mass outflow are thought to play some major roles in long period variables. Okay, so this is me, Mike Soukup. I've been an AAVSO member for almost 30 years. I'm new to the helm of the LPV section, so there's a lot of work for me to get going on, and there's a lot I don't know, but bear with me. Okay, this isn't a scientific talk. I'm not really the guy to sit here and tell you all about the beauty of all the different LPVs, and that's a good thing for you. But so this is not a scientific talk. What it is, however, is sort of an overview of LPVs as we think of them, why we want to look at them, and about all of us, those who can contribute by observing them and by working with the LPV section. Okay, first of all, let me try a definition of sorts. What is a long period variable? It turns out there are actually many types, subtypes. It's a real mixed bag, but they're basically all pulsational variables. The majority of them, nearly all of them, are on the red giant branch, the asymptotic giant branch, and even the post-asymptotic giant branch. And as I mentioned, we have a whole lot of different types and subtypes. Again, just about all of them are at the cool effective temperature end of the Hertzsprung-Russell diagram. That basically means that they're red and yellow giants and supergiants. In terms of period, what defines an LPV? Well, I just took a stab at it, and I'll say 50 days period at kind of at the bottom end, but it really depends on who you talk to. I've not seen what appears to be an official definition. And some of them, the red, can have periods of 1,000 days or so. And I have to at least try to live. Most of them are low mass stars.
Oh,
we have
Mike.
a few high mass stars, the red supergiants, for example.
Oh, Mike.
But most of them actually begin their lives as
could you maybe try shutting off your shut off your video for a little bit,
when we start to look at them as long period variables, turn off the video.
Yeah, if you would. Your audio is cutting out, so we'll save just a little bit of bandwidth by shutting off your video there. So just
how's that?
Oh, so you can do your screen sharing, but looks like he might have just left the meeting. So we'll go ahead and give Mike just a minute to come back in. All right, well, while we're waiting for Mike to come back in, we can probably do just a little bit of Q&A, I suppose. So there were a couple questions that I saw that came through that I think were already answered, but maybe we'll catch these here again. And so Arne, I saw that John mentioned, he asked the question if AAVSOnet is interested in some fractional time from an existing or some other kind of automated telescope. Would you care to answer that question again, but just for the rest of the audience?
Sure. We do that already with the partnerships on the larger telescopes, because those, for instance, the one with New Mexico State, they are using the telescope for classroom exercises, as well as AAVSO being able to use a fraction of the time. So it is possible. The main constraint is volunteer time and programming time. It's a whole lot easier if you're using exactly the same software suite on your telescope that we're using on our telescopes, because then it's a trivial matter to insert our targets into your queue and to make sure that everybody gets their proportional time and be able to retrieve the images. If you're doing it in a different manner, then it's more complex. And to be honest with you, if you have something unique, then we will try to support it. But if it's a typical telescope, then we probably will pass on that because we just don't have enough manpower. So go ahead, Mike.
Yep.
Okay, let's see if I can limp to the finish line here.
Yeah, no problem, Mike.
Yeah, I'm gonna go fast.
Okay. All right, so we can see your screen, so you're good to go.
Okay, so I just wanted to show HR diagram of a typical long period variable. They're, as I say, they're typically on the red giant branch. They're at a very evolved state in their lives, and they come down and they make it to the AGB, and a few of them, such as probably RV Tauri's, RCB stars, are post AGB. And also we have a few massive stars. These would be in their early parts of their lives, earlier part of their lives, I should say. These would be the Cepheid variables. That is, stars that had been giants, but they make a blue loop and then come back toward the red giant branch. Okay. No talk on variable stars would be complete, even though this is not a scientific talk. But if you're going to talk about variable stars, you have to show a light curve. And this is a light curve of our prototype LPV, red giant, known as Myra. This is out of a few years worth of the AAVSO database. I do want to include a light curve of one of my favorites, which is an RV Tauri star. These are typically yellow supergiants, and they are known by the fact that they have alternating minima in their periods. So at one part of the cycle, total cycle, you have a deep minima. The next go around after a maximum, you get a shallower minimum, and so on. This happens to be AC Hercules, which is one of the more regular RV Tauri stars. I find them pretty interesting. Okay, so why do you want to look at long period variables? Because they can tell you an awful lot about what's going on inside the star as it relates to stellar evolution. The science of studying variable stars is known as astroseismology. By studying the pulsation characteristics, observational, theoretical work, you can actually glean what is going on inside the stars that we can't see directly. And also, because these stars are at the late stages of their evolution, their lives are actually sped up. They're evolving faster and faster as they have aged. And so we can actually, with a lot of data collected, we can start to see some changes in the variability that is an indicator, again, is what's going on inside the star. However, since there are an awful lot of LPVs out there, Myras, the red giants, and so on, and all the semi-regulars and whatnot, because there's a lot of them out there and we're looking at a lot of them, you're going to occasionally catch one that's going to be doing something different. It isn't the same old just forever. There will be some abrupt changes that we're going to catch. And once again, we try to do some theory and observation to figure out what is causing these abrupt changes. Again, evolution in the interior of the star. Observations over a very long term, LPVs, that's very important. You got to keep looking at them. And this is really how we're going to learn about what's really going on at the end stages of these stars' lives. Data from everywhere in any one, whether it's a survey telescope system or the amateur in his backyard, all those points, data points, add up to something pretty important and can tell us a lot. Okay, before I get to my last slide on the LPV section itself, what can all of you guys do out there? Contribute. There's an awful lot of LPVs of all the various kinds to look at, some more than others. The Myra type red giants are very, very numerous. Arvitaris, much less so because their stage of evolution is very rapid. So you're typically not able to see a whole lot at any given time because they're evolving so fast. You don't have to have a dark sky site, although I know we'd all love to have one right next door. But fortunately, if you don't have such a site, many LPVs, again, the red giants in particular, they're bright. So you can see, within limitations, you can kind of see a lot of them from your backyard. Many of them, because they're bright, even the big survey instruments that are coming online now that just gobble in enormous amounts of data, they have their limits, and that's a bright limit. The mini LPVs that we look at, want to look at, they're too bright for the telescopes, the survey telescopes to look at. So there's a niche here for amateurs who observe with smaller instrumentation. Legacy stars, I just want to say here that AAVSO's bread and butter have been the LPVs, and we have a lot of data, a lot of observations that go back before the founding of the AAVSO even. So, but these guys, a lot of people say, well, they're just old stars. We've been watching them forever and ever. Why bother to go back and look at these objects about which so much has been observed? Well, that's exactly the point. We have a lot of data already. Why not continue to add to it and keep on learning? Again, as we learn more and more about LPVs, we see more and more, discover more, whether it's a survey instrument or amateurs, what have you. We're seeing more of them. We're more likely to catch them doing something new or different. Keep observations to do that are very important to help us in our understanding. Equipment couldn't be simpler. It's possible to do LPV photometry of sorts just with your naked eye. If you can, go to binoculars. An awful lot can be done with a decent pair of binoculars and obviously a telescope. Telescope and an eyepiece. Again, your range of targets is rapidly enhanced. Electronic imaging, if you're into CCDs or CMOS cameras, what have you, then add that on. And again, your horizons will be greatly expanded and you can do more and more. But you don't have to have a lot invested in equipment. You don't have to observe them every single night. For some types of variable stars, eclipsing binaries, what have you, sometimes you need to observe them all night long, or perhaps every clear night you can get. LPVs, you don't have to be out there that often. I'll take, again, a sort of a stab at it. You can observe most LPVs every 5 days, a week, 10 days, whatever, and you're still going to get a decent amount of useful data. I would like to make a plug for doing data mining and data analysis on LPVs of your choice. Compared to where we were 30 years ago, AAVSO has some really great software tools to do this data mining and light curve analysis and so forth. So if you're kind of scientifically inclined and you've got some math skills, whatever, I really suggest trying to do some of this more software-oriented work. I'm starting to do it myself, and it's pretty addicting. Lastly, what is the section? That's what we're coming to. The AAVSO's mission is, if I remember it correctly, is to allow anyone, anywhere, the opportunity to contribute as citizen scientists through the vehicle of observing variable stars. So we have an LPV section. Our job is to maintain the web pages. We have a pretty good set of web pages for LPV, but admittedly, it needs to be updated. A lot of things have happened, and we, in the field, and they're a bit stale. So one of the things I'm working on is to try to get these things updated and hopefully be more useful. We have an LPV forum. That's our primary vehicle for communication and spreading information around. Another part of our duty is to, the part is really just to interface with people who want to be section members. Anybody can be a section member. There's no application to fill out. You don't get a gold or platinum card, but that's why it's free. So we don't have to worry about all that overhead stuff. So anybody who just wants to contribute, participate in the section, ask questions, whatever, you're a section member. Talk to us, use the forum, use email, just participate. And I think you'll find it exhilarating to have people to talk with about your interest as well, and people who know a lot. We have some scientific advisors, and these are people who are professionals. They've been involved in variable star work for a very long time, and they can answer a lot of questions, give you a lot of practical advice, and they can help you out with, okay, what might this mean? What's going on here? So really the section is, I call it a clearinghouse. As part of that, we also provide some guidance tips, observing techniques, whatever. And we haven't got an official project going yet, but we want to have multiple, at least eventually, actual research projects. No doubt we have LPV members who do such things on their own. But if we can band together for bigger research projects that involves multiple members participating, I think we can get a lot of useful stuff done. And I think that we can get some projects going that are actually publishable in the AAVSO journal or elsewhere. So please join the LPV section. All you have to do is participate, contribute if you can, and I think it's a worthwhile use of time and effort. And on my end, I want to help you guys too. And if you ask questions I can't answer, and there would be many of those, I can find the people who can. So that's pretty much it in a nutshell. I'm sorry I was rushed through here. I don't know how much of this has come through or not, but so here endeth the reading. Here ends the presentation. And thank you very much for listening.
Thank you, Mike. And actually, it all came through perfectly clear. So thanks for.
It was a little rough here. Like I said, I keep waiting for that moment when everything freezes, and I get that unstable internet connection. So if it's a bit rough, I apologize. But something I do want to say is I hope to do more of these things with fewer technical problems, and we'll get more into the science of LPVs, the more technical end. There's really a lot. There's a lot of territory in LPVs, and the evolution of all these stars of different types. There are linkages. There's a star at one stage of evolution can behave a certain way, but if it's got a similar mass and chemical composition to another star, but that star's in another phase of evolution, we can learn to start to tie these things together and get the big picture of in stellar evolution. And that's why we have so many types. We have so many stars in these different stages. So thank you all very much. And I'll make a plug for AAVSO. If any of you viewers are not AAVSO members, I would strongly encourage you to join. I have met some really super people thanks to AAVSO. If you've got an interest in the topic, I think you'll enjoy the opportunity to interact with and even socialize the meetings with these folks. Okay, that's it for me.
Yeah, thanks, Mike. And go ahead and stop your screen sharing here.
Okay.
I'll get that for you. If you want to bring up your video again, it should be good now.
Okay, here we go.
Yep. The next thing we'd like to do is just move on to the Q&A section. And so we've got about 18 minutes remaining here where we can go through that. And so I've noticed that several of the questions, so again, if you have questions for any of the presenters, please go to the bottom of your screen and there should be a box that's labeled Q&A there. Go ahead and bring that up and type your question in there so that I can follow through and make sure that we can get almost everybody's questions answered. So I'd like to follow up on just one more question that I saw that got asked, and well, actually a couple more that I saw that got asked that I'd like to follow up with. The first of which is the crossover between AAVSOnet and the High Energy Network. And Barbara Harris here asked if it was possible to write an AAVSOnet proposal to actually be able to respond to a high energy network target. So Arne, I think that's probably for you.
Yeah, well, there's two aspects to that. As HB mentioned, I mean, there are things that are just sort of monitoring, HENs and QSOs and things like that. That's just a target, variable star equivalent target. And it's no problem at all to enter something like that into AAVSOnet Q. The real question is if you want to deal with transients, you know, LIGO gravitational wave events or something like that. Then what you need is a real-time interrupt into the AAVSO network. Bob Denny put something like that into ACP, which is our main scheduler. He has a VO event handler, but that hasn't been exercised in a number of years. And I assume it's still there, and I assume that it still could be used, but we haven't tried it in quite a while. But back in the sort of 2012, 2015 era, we did a number of gamma ray burst afterglows that way, and we're quite successful at observing them even with small telescopes.
Oh, very cool. And then we'll follow up with a question for HV here from Andrew. And they were curious, what would be an example of a visual magnitude for kilonova? And then following up on that one, John Hoot was asking, what's the search radius for kilonova?
Yeah, both actually depends on how many instruments see the kilonova at the same time. So if it's just one gravitational wave detector, the sky localization is basically probably hopeless because it's thousands of square degrees and you just don't know where to start looking for it. And if you're really lucky, then you have a gamma ray burst at the same time, and or you have it seen by 3 detectors. Currently only 2 are online because the one in Italy is a bit kaput. And but if we have three going and three see them, so if we're lucky, we are talking like tens of square degrees, many 10 of square degrees, which is not so bad, because I mean we know that these events happen inside galaxies, and we also get a distance estimate from the gravitational waves. We probably, I mean, for if we are talking about things that are visible for amateurs, we are probably thinking about stuff that is closer to 100 megaparsecs. And for that, we have pretty complete galaxy catalogs. And there's roughly one galaxy per square degree in the sky within that distance. So one would actually then look at one galaxy after another. So maybe we have to check a few dozens of galaxies one by one. And if you have more people like that and you are subscribed to something like the Kilonova Watcher collaboration, then I mean, they give different galaxies to watch to different observers. So the work is spread among observers to enhance the chance that is magnitude. So the one event that we know at the time of optical discovery, like 10, 11 hours after that, had a magnitude of 16-ish or 17-ish. And we have no idea what the magnitude was in the hours before that. Probably it was kind of like at the peak at that time, but there's no way of knowing. It's also quickly changing in color. It probably starts very blue and then goes to the red very, very fast. So if you have infrared filters, that might help at a later stage. And these evolve pretty rapidly. So you don't want to read in the newspaper about it and then observe it 2 days later, because then probably it will not be accessible to an astronomer, to amateur astronomers. You want to be there within the first few hours. But then I think you have a good chance if we are lucky and it's close. I mean, the last one was at 40 megaparsec. I think we cannot hope to get one like that again, but I mean, the gravitational wave detectors can see up to about 150 megaparsecs, these events. So yeah, then you can do the inverse square math yourself. So it's not super bright, but it's well in the amateur regime.
Yeah, and a follow-up question about one of the spacecrafts that you were talking about. They were curious for the Arduino detectors. What telescope do they use, and what is its overall field of view?
Arduino, I mean, those are these little. I'm not sure what that relates to. Can somebody explain that to me? I mean, that's like this credit card size.
Little computers. I think they were talking about, there was a satellite that you displayed that had a couple of detectors on it. There was perhaps a visual.
Yeah, I talked about Swift and Fermi. And Swift has a gamma ray telescope with a pretty good for gamma rays optical spatial resolution, and it also has an X-ray telescope and an ultraviolet and optical wavelengths telescope on them. Actually, pretty small one. I think also just 6 or 7 or 8 inches only, but I mean, it slews rapidly to the point and is then looking at wherever the X-rays or the gamma rays point them.
Yeah, terrific. And not necessarily in the high energy network domain, but there's all these interesting gravitational lensing events that occur that require fairly rapid follow-up as well. So if the underlying physics for high energy things don't interest you, gravitational lenses are always really pretty interesting to observe. So the next question here is from Patrick Kavanaugh, and he's directing the question to Mike. And he said, would you recommend going to the AAVSO annual meeting to do the workshop on Python, or something similar to learn about how to do data mining research on LPVs?
I'm pretty much, when it comes to programming, I'm self-taught. I did notice that at the last American Astronomical Society meeting, they actually did offer a 2-day workshop on Python programming. I guess I'm too old-fashioned. I tend to go get a book and sit down and kind of slog through it. Yeah, you'll need, if you want to do data analysis, data mining, it's pretty good idea to have some kind of programming skills. Python is a great one. There are any number of others. There's the old favorites of mine, C programming and Fortran, but there are other languages like Julia, for example, that are very, very useful and have an awful lot of tools and libraries available for them. So yeah, if you want to get into this, well, let me just back up and say that AAVSO already has some really good tools that exist, written by people who know what they're doing, and they're constantly being debugged, updated, and so on. VStar is a good one for light curve analysis. There are books on the subject, one written by a fellow who worked for AAVSO for quite a while on how to do light curve analysis. So yeah, you've got to do some book learning, and it's a good idea to try to get some computer skills. I don't know if lately we've had any kind of programming courses at our meetings. I don't recall seeing any offered that I can remember.
Yeah, the next one at the AAVSO's 112th meeting, Dr. Matt Craig will be presenting a Python workshop, and so might be worth checking out his workshop.
Python is a good one to load, because there are so many programs already out there, so many tools or apps, as they say. And so, yeah, Python is a good one to work with. A lot of really good software is written in Python.
Yeah. So if you're interested in learning a little bit more about Matt Craig's Python workshop at the upcoming AAVSO meeting, it will be offered both in person and online. So it'll be a hybrid workshop. You can go to aavso.org/112 for the 112th meeting, and then just find the description in there about the workshop. It is limited to 20 people in person and 20 people online. Okay, so the next question will swing over here. Timothy Weaver is asking whether or not a Dobsonian telescope with a planetary video camera could be used for doing bright star photometry at a high frame rate with relatively short exposures. Either Peter or Arne, would one of you guys want to take that?
Okay, I guess I'll start. I think it may be possible. The best way to figure that out is to put the camera on your Dob, point at a known, probably star cluster, and try some short exposures, and then examine them on your computer and see how deep magnitude-wise you can get. That's the best bet. I think generally speaking, start off with an exposure time of your focal length divided by 500 in seconds, and work from there. Generally, that's, at least using DSLRs, focal length of the lens divided by 500 is almost the longest exposure you could take without trailing.
Terrific. Arne, do you have anything that you'd like to
add? No, not really. I mean, it's one of those things where you have to experiment, as Peter says. Try it and see whether or not you can do it. Generally, the video cameras tend to be 8-bit cameras, and so you're limited in dynamic range. So you may have some issues there, but if you're stacking a bunch of the images together before you go and do your photometry, that aspect probably goes away as well. So it's just, you know, you got to experiment and see whether or not it's going to work for you.
Terrific. And my first project that I really got involved with doing stellar photometry was with a 10-bit DSLR camera that I just literally sat on a rock and pointed in the general direction. You know, it worked out reasonably well. So you know, you can get data from relatively modest devices, but it's just a question of going out and experimenting and seeing how well it works. And then I think this is a follow-up question that was asked to something that Arne already answered, and maybe this is both for Arne and Peter. They were just wondering if any company is still making CCD cameras for professional astronomers, and if so, who they might be.
The main well, E2V is probably the main scientific CCD manufacturer at this point. And a lot of the companies like FLI and so on still make cameras that use these sensors. So you just have to look around a little bit. I think everybody's probably got a camera with one of those in their camera line, but they tend to be very expensive. You're looking at tens of thousands of dollars for one of those cameras. It's not like a small CMOS camera. The main advantage of the CCDs in the professional world is twofold. One is that you get big pixels, and they all have long focal length telescopes. So the bigger the pixel, the more important that is. And the second one is that you can tailor them for specific wavelength ranges. So you can do the deep depletion and things like that to get very high efficiency in the red, or you can tailor them to be a very blue sensitive detector. And so they have more control and more customization when they're dealing with professional CCD sensors. But that's not what you normally do in the commercial world these days. It's mostly you get what Sony provides for you and you live with it.
And Terry here reminds us that Teledyne still makes some CCD-based detectors. And if I recall correctly, there's Diffraction Limited is even offering, I think they call it like an eye transplant or something like that, where you can take a CCD sensor from an older camera and move it over into a newer physical package with like a modern USB 3 interface. And so that can really speed things up quite a lot. But when I looked at the price of that, it bordered on the price of a new 16-bit CMOS camera. So need to think carefully about what you'd like to do in terms of the capabilities and the science that you'd want to be driving towards.
One nice thing about the CCD cameras is that there are a ton of them available on the used market right now. You know, if you go to Cloudy Nights, you know, the for sale section, there's a lot of them available. And, you know, they keep working no matter how many photons they see.
Yeah. Bill Golf here asks a question of, he's discussing about how the high energy targets would really benefit from like the virtual observatory events. And he asked a relatively generic question about the virtual observatory, which is there really any consideration to reestablishing the VO? Is it still up and running? Because I know back in 2010 time period, it was really quite popular. And I know there's still lots of services out there that are offering VO events, but is it still a real driving factor in modern astronomy? So I don't know if Arne, maybe you might have the best knowledge of this one.
Oh, I doubt it. I think Heinz probably knows better than I do.
I mean, the thing that I associate with VO events is this XML language to describe, and this is not without controversy. GCN in its current form uses VO event XML in a lot of their messages from Swift and Fermi and whatnot. But they actually want to move to JSON. So many see this as overly complicated and difficult to parse and not Python friendly and whatnot. So Yeah, I'm not quite sure this has a big future, but I mean, there might be more to this VO concept than just this XML language.
Excellent, thank you. So we're just right at the top of our time, so we're going to go ahead and wrap it up. And so I'll start my closing announcements here. And so first off, I'd just like to thank Arne, HB, Mike, and Peter for their time here, for coming on over a weekend and telling us about the different sections that they represent. And so, of course, I'm sure that the audience really appreciated you guys being here as well. I'd also like to thank our sponsor again, Voice Astro. As I mentioned earlier, they're sponsoring this webinar series in whole throughout the entire year. And so without their support, we wouldn't be able to bring this to you. And so again, if you haven't heard of the Voice Research Initiative before, they are an educational foundation that provides online astronomy courses, observatory resources, and research experience to students, student teams, and schools to learn how to perform observations, conduct research, and publish their scientific results in various journals like the Journal of the AAVSO. And if you would, please go ahead and check out their website, which is at voice-astro.org. I'd also like to thank everybody in the audience who joined in today. It was really great having you guys here, very friendly conversations in the chat, as well as good questions that were answered in the Q&A box. And so I'm glad that you could be here, and we're very grateful for your support. I'd also like to let everybody know that today's broadcast is actually being recorded, and it'll be available on the AAVSO YouTube channel within the week. And then when you leave the webinar today, you should automatically get a survey, and it's very appreciated. It's great if you could go ahead and respond to that survey and provide us with a little bit of feedback so that we can understand what you liked about the webinars and how we can plan our webinars for the future. We're actually starting to look at our whole next year with the webinar series. And so if there's any type of events that you'd like to see more of, things that you'd like to see less of, please let us know. And to close, I'd just like to express one last thank you to Arne, HB, Mike, and Peter for spending their time with us this Saturday. Thank you very much, guys. And so from all of us here at the AAVSO, we appreciate you being here and wish you a great weekend. Take care. Bye-bye.